Hello students, welcome to Dr. Shorav sir classes. So as you know that we are solving these questions from UPSC 2021 paper of maths optional, and we are solving this of paper 2. So in the previous video I have solved the question 3a and 3b. So here we will solve with this the last part of this question 3, the 3c. So let's start with the question. So convert the following LPP into dual LPP. So minimize z is given that x1 minus 3x2 minus 2x3 subject to these three equations where x1 x2 is greater than or equal to 0 and x3 is unrestricted in sign. Okay, so given that we have been given the z is equal to given this x1 minus 3x2 minus 2x3 subject to this equation 3x minus 3x1 minus x2 plus 2x3 less than or equal to 7. Let us take this as equation 1. 2x1 minus 4x2 greater than or equal to 12. Let us take this equation 2. And minus 4x1 plus 3x2 plus 8x3 equal to 10. So let us take this equation as 3. And we have this given, this x1 x2 is greater than or equal to 0 and x3 is unrestricted in sign. So the constraint in equation 1 you can see in this equation is of less than or equal to 10. And this problem that is given, so this is a minimization, right? So all the constraints over here should be of this type, the greater than or equal to sign, right? So what we have to do, we will multiply this equation 1 by minus 1. So if I multiply this, what we will get? So it will be 3x minus of 3x1 plus 3x2 minus 2 3x3 greater than or equal to minus 7, right? So now this is the new equation, and the third equation 3 you can see that with this equality sign, okay, equality sign. So what we will do with this, so it is given as minus 4x1 plus 3x2 plus 8x3 equal to 0. So we can write this as less than or equal to 0. Similarly, it can be written as 4x1 minus 3x2 minus 8x3 is greater than or equal to minus 10, right? So this is the, it can be written as minus of 4x1 plus 3x2. So this is minus, this is plus. 8x3 is greater than or equal to 10. So this is the equation number, new equation number 2. Okay. So now what we will do, so we will put this x3 is equal to x3 prime minus x3 double prime, so that x3 prime and x3 double prime must be greater than or equal to 0, and the primal can be written as z is equal to this minimize z. Okay, I can write it over here. x1 minus 3x2 minus 2x cube prime plus 2x cube double prime. So subject to the equation 1, the equation. What is the equation that was given? Minus of 3x1 plus x2, this will be minus of 2x3 prime plus 2x3 double prime. It is greater than equal to minus 7. So 2x1 minus 4x2 2x1 minus 4x2, it is given is greater than equal to 12. And this equation will be 4 of x1 minus 3x2 minus 8x3 prime plus 8x3 double prime is should be equal to greater than minus 10. Okay, so from here we can get, so this is minus x1 plus 3x2 plus 8x3 prime minus 8x3 double prime is greater than equal to 10. So from here we can write this, that x1 x2 x1 x2 x3 prime and x3 double prime, that is greater than equal to 0, right? So dual to this LPP will be, now continuing over here, so dual to this linear programming problem will be, maximize W, which is equal to minus of 7yy y1 plus 12y2 minus 10y3 plus 10y4. Okay, now what is be the subject to equation? So now here it will be all less than equal to type, so here it will be subject to the equation minus of 3x1 plus x2 minus 2x3 prime plus 2x3 double prime greater than equal to minus 7, right? So here it will be, okay, so here it will be, we have been this of the type 7y1, so this is the equation. Now maximize this equation, the subject to it will be minus of 3y1 plus 2y2 plus 4y3 minus 4y4, it should be less than equal to 1. And so from here you can get that, so y1 minus 4y2 minus 3y3 plus 3y4, it should be less than equal to minus 3, minus of 2y1, so it should be plus 0y2 minus 8y3 plus 8y4, it should be less than equal to minus 2, and it will be 2 of y1 plus 0y2 plus 8y3 minus 8y4, it should be less than equal to 2. And so from here you can get this y1 y2 y3 y4, it should be greater than equal to 0. Okay, so this can be written as the maximize of W, okay, max of, can be written as minus 7y1 plus 12y2, okay, minus of 10y3 minus y4 is subject to, so the equation will be minus 3y1 plus 2y2 plus 4y3 minus y4 less than equal to minus 1, less than equal to 1 it will be. So here it will be y1 minus 4y2 minus 3y3 minus y4 it should be less than equal to minus 3. So from here you can get this minus of 2y1. The equation will be 8 of y3 minus y4. This is equal to less than equal to minus 2. Okay. This is 8. Okay. So this will be, we can write this as y2 of y1 plus 8 of y3 minus y4. It should be is less than equal to 2. Then this all the limits are out. So from here you can write this y1, y2, y3, y4 is greater than equal to 0, right? So the terms y3 minus y4, this and this, okay, in both the objective function, okay, and constants of the dual. So this is always whenever there is an equality constants in the primal, then this new variable y3 minus y4, that is going to be equal to u1, becomes unrestricted in sign. Okay, becomes unrestricted in sign, and being the difference of the two non-negative variable, okay, these are the two non-negative variable. So the above dual problem will take the form, okay, will take the form is mean of w, minimize this, minus of 7y1 plus 12y2 plus 10 of u1, right? So subject to this equation, so here it will be minus 3y1 plus y2 plus 4u1 is less than equal to 1. So y1 minus 4y2 minus 3u1, it should be less than equal to minus 3. The minus of 2y1 minus of 8u1 less than equal to minus 2. So 2 of y1 plus 8u1, it is less than equal to 2 only, right? So u1 u2 is greater than equal to 0, and y1 and y2, sorry, and u1 is an unrestricted sign, right? So it can be written as, finally, so I'm writing it elaborately so it can help you to know that what you have to say. You have to answer in this manner in the exam actually. So in this sort of this maximize as much point as you can. So that is maximum of z, it will be 7 minus of 7y1 plus 12y2 plus 10u1. So subject to equation minus of 3y1 plus 2y2 plus 4u1 is less than equal to 1. Okay, y1 minus 4y2 minus 3u1, it should be less than equal to minus 3, and minus 2y1 plus 8u1, it is equal to minus 2. Okay, so here u1 and u2 is y1 and y2 is greater than equal to 0, and u1 is unrestricted. Okay, so that's the solution to our problem. So this solves question 3C. It's quite elaborative and explanative, you can see. So that is the way you have to solve this problem. So okay, so the only way it can be happen that you have to practice a lot this thing. And in UPSC the question never be so that of means it is not that it is not solvable at that moment. It is solvable if you have the practice of the previous year questions. So solving previous year question is one of the most important thing in actually in this UPSC. So you get to know what the pattern, and also in some cases you will find this the questions will be more of this like whatever the questions in this year, so that it represents the previous year also. So that is the thing. So see you in the next video with this next question 4, question number 4.